Om Sri Sai Ram. Hearty welcome to Sri Sathya Loka Seva Gurukulam online classes. And I think all of you are full of energy now after taking suitable breakfast or lunch, because we are talking about one of the most important form of energy, namely electrical energy. And I need not tell about the different sources of energy. We already studied. We have studied about light energy, sound energy, magnetic energy, atomic energy, solar energy, and so on. So this electric energy is also one of the important branches of energy. And one common experience, especially in rainy seasons, all of you have seen how the clouds will move from one place to another, right? And when the clouds move at some part of day, we find a flash of lightning, isn't it? So this flash of lightning is an example for static electricity. When you say electricity, there are two types. One is static, another is current electricity. So the static electricity will come across in our daily life in many places. And also you must know how this electricity is produced. Can I name some of them? Okay. All of you have seen cell, what you call. What is the difference between cell and battery? When many cells are joined, we get battery. If there is one, you would call it as cell. From cell we can get energy, electric energy, right? Because there will be a chemical reaction taking place, and because of chemical reaction it leads to electrical energy. There will be one positive in the middle rod, and there will be negative made up of some chemicals. And when you connect these two by means of a wire and connect it to a bulb, the bulb glows, is it not? So that is one source. Also you have seen in the previous chapters about how electricity is produced from coal, is it not? And by the, we have got power plants like that of in Raichur, Shakti Nagar. And also electricity can be produced from nuclear energy. The peaceful purpose of nuclear energy, that also gives electric energy, is it not? And by chemical reactions, by nuclear reactions, all these produces electricity, and even in the cells or battery also. And about uses of electric energy, you can go on listing out, not one or two. In your house only we can see bulbs glowing, is it not? Grinding machine, and then you have television, and then you have fans, electric ovens, and so on. The list goes on. So there are innumerable number of uses. Every day there will be some other gadgets coming to the market showing about the use of electric energy. And also you have seen briefly in the previous class of 7th and 8th about the effects of electric current. There are three important effects. One of them is heating effect. I was just now telling about the oven. That oven shows the heating effect of electric current. And then you have boilers, ironing, iron box. How many of you know how to iron it? Yeah. While ironing, there will be heating effect. That coil gets heated up, and that gives helpful for the ironing purpose. And magnetic effect. You heard about dynamos, right? You heard about these motors. The electric motor is a very good example of the magnetic effect of electric current. And you might have heard about cranes, that is also magnetic effect. And about chemical effect also, what you call electrolysis, the voltammeters, the water voltammeter, copper voltammeter, all those briefly are studied in the previous class. So it shows that there are some effects of the electric current, and these are some of the effects which you already studied. Now we will see one video which you every day will experience, okay? All of you see now in the video, there will be flash of lightning. And how does the lightning comes? That is because of two charged clouds. When they come near, lightning is produced. One cloud having the positive charge, when it comes in contact with a negative charge, we get lightning. So that is a very natural phenomenon which produces a very high temperature of the order of say 30,000 degrees Celsius or even more. Okay, but it is a challenge. Even up to today, the scientists are cracking their heads to get that energy in the laboratory. It's not possible so far because it comes in a flash of a second. And if that energy is used in laboratories, it solves many of the electrical problems of today. Okay, let us see, you may also become a scientist and discover some devices as to produce that same electric energy in the laboratory. Now today we will see some of the interesting things. For example, what is electricity? It is not a city. Just like Bombay, Delhi, Calcutta, Bangalore, it is not a city. Electricity is a form of energy, and it consists of two charges, namely positive charge and negative charge. What do you mean by charge? Charge is nothing but the particles having a, positively or negatively. All of you know every atom consists of a nucleus, is it not? And the nucleus will have two types of particles, namely protons and neutrons. And there will be electrons going around. And when two bodies, are rubbed against each other, or any external force is applied on them, there will be transfer of charges. And what do you mean by transfer of charges? Transfer of charges means the electrons from one body will move to another body. See, this is a very common experience. You can try now only by taking a comb, plastic comb, rub against your hair and bring it near paper pieces. You can try there sitting only, and you might have done it already. So when you do like this, by rubbing so, what happens? The charges that are present, in the plastic attracts the paper pieces, not paper, please note. See, these are paper pieces. They will be attracted by the comb. So a plastic comb, when combed with a dry hair, brought near a piece of papers, attract the pieces of paper. This happens because the comb gets charged or electrified. So it is only in case of dry hair, please note. Because wet hair or oiled hair means the charges will not transfer. If you take a dry hair only, it happens. And why does it do so? That is because of the electrons. Okay. And this electricity is called static electricity. That is already present there. Even our body also has static electricity. Some of you have got terlin shirts, not the cotton shirts. Terlin or terracotta or rayon or whatever it is. Artificial things. Na? When you remove your shirt, some sound will come, right? In the night time, flashes comes. Have you observed? When you remove your shirt in night times, some sound will come, chat, 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 chat. And what is that? You will not fear because it is your own body giving that. So it is because of the friction. So that is what is called as static electricity. The electricity developed on a body on rubbing with another body is called static electricity or frictional electricity. It happens by friction. I need not give example for friction. We are all standing or sitting in a place because of friction again. If there is no friction, we will slide off. When a cricket ball, when it is shot, it will move to a certain distance and it stops there. Why it stops? Because of friction between the earth and the ball. So also this electricity will be seen only when you rub one substance with the other. If you not rub means you won't get. So the rubbing is very important here. That's why it is called as frictional. If you do not rub, the electrons will not be transferred. Okay. And for example, amber rubber is there with a woolen cloth. It is not wooden cloth, it is woolen cloth. So when you rub it with woolen cloth, this amber rubber will be charged. Or you can say glass rod rubbed with silk. So when a glass rod rubbed with silk produces electric charges. Here glass rod acts as positive and silk acts as negative. So glass rod will be positively charged and this charge will be transferred to other substances. That is why it is called as static electricity. Even the lightning also is an example of static electricity because clouds will be having charges. One may be positive, one may be negative. Only when positive and negative come here, law of charges, unlike charges attract each other. Like charges repel each other. So when plus and minus come together, there will be electricity. And that is what is called as static electricity. And it was Benjamin Franklin. See the photo. How nice he looks, na? He must also have suit and boot. Then he will have look like this. So he is Benjamin Franklin. He was very interested in kites. How many know how I played with kites? Yeah, in this season, rainy season especially, that too in COVID time I did not tell, most of you have a lot of leisure, right? You can prepare some kites. How many of you know how to prepare kites? Very interesting skill it is. Please try it. Okay. So there will be competitions also, they will give prizes also. In that kite, Franklin, when he was very young, he was playing on kites. And very interesting, everybody want to see that their kites are above. Mine should be top. There will be competitions, right? So one day he thought, instead of having a thread, let me have a wire. Small thin wire, we have to call it a binding wire. So he held the kite by the help of a binding wire. And in the end of the wire, he had one key. That key was tied to the wire. And in the top of that, the kites that was going up, that was a rainy day. There was a lot of thunder and lightning. For his surprise, the lightning struck against his kite. And that lightning charges passed through the wire because it was metallic. And he got shock. Of course, mild shock because he had shoes in his legs. There was a shock for him. Oh, a very interesting thing he thought. Oh, here is something very interesting. Everybody has seen lightning, everybody has seen clouds, but this lightning also passes through bodies. What type of bodies? That is wet. When the body is wet, there will be flow of electrons through the body, and then it becomes a conductor. So because he had a metallic wire, it passed through the wire. And so then he started doing a lot of experiments with different kinds of substances, and then he comes to conclusion that there are two types of charges, namely positive and negative. And there was one more scientist called as Thales. You might have heard his name in mathematics also. Thales' theorem about similarity of triangles. So another Greek scientist, Thales, if a piece of amber, other name of amber is electrum in Greek language, is rubbed with a woolen cloth, would attract light feathers and pieces of leaves. So casually, it is not done as an experiment. Casually, when amber was rubbed with cloth, it attracted leaves, pieces of leaves and feather, etc. So the Greek name electrum, that is how the word electricity came. Electric charges, electron, etc. came because of the word electrum. And this electrum was the basic or the foundation, how the name electricity came. And it was Gilbert, Dr. Gilbert, named the amber-like substances as electrica, which became electrically charged by rubbing. So when he concluded that some bodies acquire electric charges on rubbing, but it is not touched with a conducting body in contact with ground, the charges leak away to the earth. So that is what I said about Franklin. That will go to the earth. Luckily he had shoes, that's why he was saved, otherwise he would have collapsed, because our body is a conductor of electricity. So you should be not in touch with the earth, because earth is a very good source of charges, a huge source of charges that will flow to the earth. Okay, and that is how the word electricity came. Now here is one experiment to show about the transfer of electric charges. And materials required were two hollow straws. You know what is straw? Straw is nothing but what you use for taking juice. If you go to a juice shop, they will give some, say, sugarcane juice or whatever juice you have. They give one straw. So like that, two hollow straws are taken, and small pieces of paper. That is just to show how the attraction takes place. And a piece of silk cloth. Why do you want silk cloth? For rubbing. Okay. Two pieces of threads, 50 centimeters in length. Small piece of threads. And one small glass bottle. These are the required things. You can also try to do it. A piece of cellophane tape, just to paste the thread. A pair of scissors, just to cut these things. So these are the materials required. You note down: two hollow straws, small piece of paper, a piece of silk cloth, two pieces of threads, small glass bottle, a piece of cello tape, a pair of scissors. Okay, that are the materials required. Now how to do it? One straw is to be taken at its center and is to be suspended from the edge of a table. So you must bring one straw to the edge of a table. It should be suspended with the help of a cello tape. Suppose this is a straw, we have to put a cellophane tape in the end of the table. That is the meaning. So that it stands horizontally, let it come to rest. Now the other straw is to be brought near the suspended straw and observe the effect. So you have to bring the other straw. So this is like this. See here. This is the straw kept in the edge of the table. So you have to bring another straw here. And next stage is you will observe that there is no effect. So one straw brought near the other straw will not have any effect. Okay. Then we will say one step forward. That is, now rub the suspended straw with a piece of paper and bring the other straw close to one end of the suspended straw. So rub it and bring it near this, like this, This you have to bring it near. So this is how the rubbing is done. Okay. We will observe that the suspended straw moves towards the straw in your hand. So it will be attracted. Just as the plastic comb is attracted by paper pieces, so also one of the straw is attracted by the other. That is by rubbing. Okay. Now rub the second straw which is in your hand with a piece of paper and bring it close to one end of the suspended straw. So now you have to take the second straw and you have to rub it and bring it near the other. So what is that? We observe that the suspended straw moves away or repelled away. So when you bring it to the suspended one, it is suspended by a thread and it is repelled away. Why does the repel take place? Because of like charges. When there is like charges, we have repulsion. What do you mean like charges? One straw negative, another straw also negative. If there are same charged, then you get repulsion. Similarly, one positive and another positive, there will be same charge. That is called repulsion. And when you get attraction, when there is one charge is negative and other is plus, or vice versa, we will have attraction. That is how the law of charges. What is that law of charges? Unlike charges attract each other. Like charges repel each other. Just as a magnet, no? You have seen magnets. If you bring two magnets, like poles repel each other. Unlike poles attract each other. So also here, this is called law of charges. And of course, you must know that it is nothing but static charges. This happens only in case of rubbing of two substances. And why does it happen? That is because of transfer of electrons. Why is that electron transfer? That is because the outermost electrons, the electrons in the outermost orbit, when you rub it, they will be transferred. For example, if you are sitting in a bench, 4 members are sitting. Now fifth one want to come in the same bench. For example, teacher is doing an experiment. You want to see it. A teacher will tell you a story. You want to hear it. You are in the last bench, you can't see or you can't hear. What do? You come front. And when you come front, when you sit in the first bench, the boys or girls who are sitting there may not allow you. Then you just push. No, I want to sit here only. When you push, what happens? The fifth one will be terminated because of friction, because of pressure. Okay. So, if there is a like charges, as in case of minus minus or plus plus, there will be repulsion. If it is unlike charges, say one is plus, another minus, or another is minus and plus, you have attraction. Okay. This is something about static electricity. So what you can infer from this? Like charges repel each other, unlike charges attract each other. and two types of charges, namely positive and negative. How do you get plus? When there is more of positive charges, we got plus. When there is more of negative charges, you have minus. Now how to detect it? There is a device called as electroscope, about which you are going to study in next PU class. Electroscope is a device of detecting charges, whether given substance is positive or negative. And the famous electroscope is, there are so many types. Famous type is gold leaf electroscope. There will be two, leaves. Earlier it was gold. Now there is no gold. They use aluminum, what you call as foils. So these foils will be kept something like this in a parallel way. And during charging, they will be repelled if there is a like charge. And during attraction, they will be coming like this. So that is what is called as electroscope, which tells about the two kinds of charges. So this is something about the static electricity, and this is other two cases where it is rubbing take place. Here is a glass bottle, you can see, and so charges developed on glass bottle and rubbing with silk. So there are different materials you can take. Here they have taken glass bottle with the silk. How do you get silk? Do you know? Yeah, Chikbalapura Kolar boys know very well, because they have seen silk. Even Ramnagara, they know very well. Chantapatna, Ramnagara and all. It is from a silk moth. There will be a worm, silk worm, what you call. It has got a kind of juice coming out of its mouth and produces a, Baba says that we are also bound, just like a silk moth, we are also bound by the body and world consciousness. It must come out. That also the worm, just go on increasing in length and breadth. At one time, it develops its own worm, its own cloth, and then what they do, they put that into a hot water or boiling water. The moth dies, the worm in that will die. They remove that thread, that is called as silk, and that silk will have charges, and that charges, when it rubbed with a glass bottle, it gives electrons. So the nature then, the charge developed on straw rubbed with paper. So glass on rubbing with silk gets positive charges. So glass straw when rubbed with silk, it gives positive charges. And whereas in case of the other substances, like say ebonite rod, or if it may be straw, ebonite rod rubbed with the wool will give negative charges. So straw also, when it rubbed with the cloth, will give negative charges. So there will be transfer of charges, and there will be two kinds of charges called positive charge and negative charges. So they will be equal in magnitude, and this transfer only will take place. See, suppose a beggar comes to your house, what will you do? Of course, we should not give money. You have to give clothes to them, or you have to give some food materials, like that. Should not throw money on the beggars, please note, because they will misuse also. So when you give something, so you will be called as the person who gives, and a person who gives will have positive, like a positive charge. Only if there is somebody to take it, then only transfer take place. So also here, when you rub a glass with a silk. Glass is something which gives out electrons, and silk is something which attracts electrons. So on rubbing, if some of the electrons are removed, the material which loses the electron becomes positively charged. Positively charged. For example, glass. And material which has gained electrons, say silk, will be negatively charged. Okay. So this is how the transfer of charges take place. And so this is the figure what you can see here. These are the straws. This is tied with the thread. This is rubbing with the cloth so as to get a charge. This is how the attraction take place. This is now rubbing the other straw with the cloth. So this you can also train with that. So there will be two kinds of forces. One is attractive force, another is, see, this is attractive force. This is repulsive force. Okay, and this was discovered by, first of all, by Benjamin Franklin, and later on Coulomb, a very famous scientist by name Charles A. Coulomb, is a French physicist. This is Coulomb, who gave a very important law called as Coulomb's law of electrostatic charges, similar to the magnetic. In magnetism also same type of law comes. He said that the magnitude of force of attraction or repulsion, if it is like charges, repel, unlike charges, attract, between 2 point charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So here is a force, and the force depends upon charges. So it is directly proportional to the product of charges. If we say there are two charges, namely Q1 and Q2, product means what? Q1 into Q2. And we call the force as F, for example. So force of attraction is proportional to product of the two, inversely proportional to the square of the distance, means 1 by r square. Means what? The distance is small, then attraction is more. The distance is big, attraction is less. For example, when the sir has not come or madam has not come to the class, what are the boys or girls doing? They will be shouting in the class. The sir is a distance. The same sir enters the class, distance becomes 0. Then everybody becomes silent. Of course, we cannot generalize usually. So here what happens? Distance is inversely proportional, and product of the charges, they are directly proportional. Come and write a formula like that. So there are two charges, namely Q1 and Q2. Let us call the distance as r. Now how do you measure this Q1, Q2? The charges are measured by a unit called Coulomb, named after the scientist. Most of the physics units are named after the scientist. It was Coulomb who found out this law. That's why it is called as Coulomb. If charge Q1 is placed at a distance of r from a similar charge Q2, then the two charges will continue to repel each other with a force. And that is how you write it. Directly proportional to Q1, Q2. Q1 into Q2, inversely proportional to r square. So if you split up like this, F is proportional to product of the two charges, is also inversely proportional to square of the distance. What do you mean inversely proportional? as one ratio increases, other ratio decreases. That is called inversion. What is directly proportional? If one ratio increases, other also increases. That is directly proportional. Okay. So if Q1 and Q2, Q1 is equal to Q2, then is equal to 1 coulomb, and the distance, let us suppose, is 1 meter, then force becomes Q1 into Q2, and here you use the unit, the standard called K. When you remove this proportional sign with the equal sign, when you make it an equation, we are using a constant called K. F is equal to K into Q1 Q2 by R square, where K is called the constant of proportionality. Its value will be 9 into 10 to the power of 9 Newton meter square Coulomb to the power of minus 2. Please learn it. 2-3 times you must tell. That is the value of K. How to get that value? If Q1 is equal to Q2 is equal to 1 coulomb, this is Q2, 1 coulomb, distance is R is equal to 1 meter, so distance is 1 meter, and this is 1 coulomb, and this is 1 coulomb, then we get the constant 9 into 10 to the power of 9 Newton meter square Coulomb to the power of minus 2. That is what is called as K. Q1 is 1 coulomb, Q2 is 1 coulomb. Distance is 1 meter. So if you apply it, you get the value 9 into 10 to the power of 9 N. What is N? N is nothing but newtons. So here N stands for newtons. It is a measurement of force named after Sir Isaac Newton. So it is a very, very famous formula. Please know it correctly. And here Q1 and Q2 are charges measured in the unit called coulomb. R is distance measured in meters. F is force measured in newtons. Okay. And you must be ready to answer any question on this. Here there are 4 quantities. In the formula, F is equal to K into Q1 Q2 by R square. Here you have Q1, Q2 and R will be given. You will be asked to find out F. Okay. Sometimes they give F and Q1, find out R. Sometimes they give F and R, find out Q. Okay. If the quantities of both Q1, Q2 are same. Like that, there will be some problems also based on this. And so 1 coulomb is the charge when placed at a distance of 1 meter from an equal like charge in vacuum and experiences a repulsive force of 1 Newton. Here the one say distance is 1 meter. So 1 coulomb of charge, and a like charge means what? Plus, if one charge is plus, another also is plus. So this law you already stated, like charges repel each other and unlike charges attract each other. So when like charges are kept at distance of 1 meter, then there will be a repulsive force of 1 Newton. Okay, then K becomes 1. So that is a law here. Now we will pass on to when you move a charge from one place to another, some work has to be done. See, for example, you have pen is there, it is on the table or it is on the desk. To take it, some work has to be done, right? So for example, bucket is there. If you want to lift, some work has to be done. You have to climb the steps when you go into the upstairs. So some work is to be done. To draw a water, some work is to be done. Similarly, electric potential at any point in the vicinity of a charge is defined as amount of work done. Work done. How to measure it? By joules, right? In bringing a unit positive charge from infinity to that point. Pen is in the table. And to lift it, some energy is required, right? So like that, to bring a unit positive charge to that point, some work has to be done, and that work is called as electric potential. So we have formula V, electric potential V is equal to W by Q, where W is the work done, Q is the quantity of charges. So ratio of work and quantity of charges. Here in this, if you are given V and W, you can find out Q. If you are given V and Q, you can find out W. If you are given W and Q, you can find out V. Okay, W is the work done, and Q means one positive charge. How do you measure positive charges? By unit called Coulomb. So, and also you can have one more formula, U by Q is equal to KQ by R, where Q is the source of energy, source of charge. Okay, this is another formula for that, but this is a very famous formula, and you will have some problems also on that. You can work out. So R is the distance here, Q is the source of charge, and Q is the quantity of charge. K is called the constant. So that is how the potential is measured. And electrostatic potential is a scalar quantity. What means scalar? A quantity which has no direction. Suppose it is direction, what do you call it? Then it is called as, come on, vector quantity. So it has only magnitude but no direction. The SI unit of that potential is work is done measured in terms of joule per coulomb. JC to the power of -1, also called volt, because it is named after a physicist called Volta. You might have heard about voltameter. It is named after the Italian scientist called Volta. So the unit is called as volt. Okay, it is a scalar quantity, there is no direction. It is one of the important measurements in electricity. The potential at a point is 1 volt if 1 coulomb of charge placed at a point possesses a potential energy of 1 joule. What is potential energy? Energy due to position. Now you are sitting there, or standing there, or hearing. So you have got some energy, that is called potential energy. If you start moving, it becomes kinetic energy. Water stored in a dam is potential. If the gates are opened, the water moves down, that is kinetic. When a ball is in your hands, it is potential. When you throw it up, it becomes kinetic. So also, 1 volt V is equal to W by Q. This 1 joule is the unit for work done. 1 coulomb is the unit for charges. So this ratio is called as 1 volt. So 1 volt is defined as 1 joule of work is done in bringing a 1 coulomb of charges from infinity to that point. Okay, infinity means somewhere from other place. Now if you have 2 points specific, and if you know it correctly, say a point called A and B, we will have what is called as potential difference. Shortly we will call it as PD, short form PD. Potential difference between 2 points is the amount of work done in moving a unit positive charge from one point to another. Suppose you have point A to point B. So to bring the charge from point A to B, and the difference between 2 potentials is called potential difference, and the unit is volt, and the device is voltmeter. Okay. So you have voltmeter for that as a device. So work done by amount of charge transferred, W by Q. Here if W and V are given, you can find out Q. W and Q are given, you can find out V. Like that. So PD, shortly called PD. P full stop D. P is potential, D is difference. When 2 points of a conductor is said to be 1 volt, if 1 joule of work is done in moving 1 coulomb of charge from one point to another. So if 1 joule of work is done to move a charge of 1 coulomb, then we have it is as 1 volt. Device to measure it is called voltmeter. All of you in your house, you have got a board, switch board, what you call. You can find this voltmeter there. It is written as V there. And one more is written as A there. A stands for amperes current and voltmeter stands for voltage. And this is a device. Exactly like this. This is a white board and below that you have black board. Here it is a index, and this of course is a laboratory model. In your house it is not like that. It will be changing. So this shows the voltage from 0 to 15. We write volt in that. So when say for example if you take a cell, if you connect it to wire and to a voltmeter, it shows about 1.5 volts. This will move up to 1.5. Okay, so different devices have different voltages. There will be big cells, there will be different voltage. Even now in electronic circuits they use very small voltages. Okay, and so everything will be detected by the voltmeter. This is called as voltmeter. And for sensitive purposes, you will have some other device also. This is for the laboratory purpose. Okay, that is what is called as voltmeter. We will pass on to home assignment. Define the units of charge and electric potential. You must define the units, not naming. How does the force between two small charged spheres change if their separation is doubled? The distance is doubled. If distance is doubled, what will happen to the force? That is the question. How will the force between two small electrical charges objects vary if the charge on each of the two particles is doubled? So charges are doubled, distance is made half. So what happens to the force? That is the question. So you have to use the formula, proper formula, and write it. Okay. So come prepared for this. Thank you.